Viewers or any other thing. Okay? I'm going to monitor each and everyone's laptop. I request the people who are in the balcony to come down. The objective of conducting the experiment is important. You should try to understand why we are doing this particular study. So what is the aim of the experiment? It is to select the ratio of MCC and lactose and disintegrate level to understand if there is any interaction of these variables with drug substance particle size distribution. So from this, what do you understand? We are trying to evaluate ratio of MCC lactose, disintegrate level, and API particle size impact or any interaction effect. So how many variables do you see in the aim? How many independent variables are there in the aim of the experiment? 3. Sure?
MCC or lactose? One.
Which are those two?
One.
MCC, lactose and disintegrate. And you are going to see the API particle size distribution as well. Do you think that is a dependent factor or independent factor?
Dependent factor.
It's the independent factor. You are evaluating API particle size, MCC lactose, and disintegrate level. These three on your formulation. How will you assess API particle size with just CCS and MCC? You are not adding API into your formulation and you are trying to assess the API particle size. Is it possible? Did you understand or you want me to explain once again the aim of experiment?
Once again.
So there are 3 independent variables or 3 factors. Okay? Moving on further, study and design type. I'm saying we are going to use a factorial design. Now what type of design is a factorial? Screening design, correct? Do you remember? Now, if you have some prior knowledge with these designs and you are confident enough, you have prior experience and knowledge, this helps you. Even you can use factorial designs for optimization. You can still do the optimization with factorial designs as well. Now, you will go for screening only when you don't know which factor is important. Now, we have some understanding on this product. That's why we are selecting 3 factors and directly going to optimize using the factorial design itself. Now, there are 3 factors which should be varied at 2 levels. That's why 2 to the power 3 factorial design. Correct? 3 variables varied at 2 levels. That is low and mid. Sorry, low and high. Now, I also said to add number of center points. So you need to include a center point plus 3. So 3 center points to be added. So go back to the morning session, you have a 3D cube. How many experiments do you expect? Sure? How? 8 plus 3. So you have 8 factorial points and 3 center points. So it's 11 experiments total. Now I have listed the factors and ranges to be evaluated. To start with that, everybody just double click the design expert version, trial version. When you open, this will be your home page of this design expert software, which is developed by Statis. Statis is the company in US who have developed this design expert. So currently it is version 13. If you have 10, 11 or 12 also, it doesn't matter because it's one of the same with slight modification. Now this is the home screen you are going to see, and you will see new design, open design, import data or design wizard. Now since you are going to create for the first time, you have to say new design. If let us say you have already worked on it previously, you can go for open design. If you have already saved previously. If it's for the first time, you are just going to say new design. Everybody on the same page? Now what do you see on the left hand side? On the left hand column of the tab, you will see different designs which are listed, starting with standard designs that are factorial. You have response surface, you have mixture, and you have custom designs. Custom designs are for customization. That is, you can design your own experimental runs. So many times when you don't have the software in your college and you have already finished your all formulations, let us say you have done 15 to 20 formulations, now you can take those 15 to 20 formulations and feed into the software to generate a new design for you, so that you can customize as you need. Now factorial, you will see randomized designs. Randomized, if you remember morning, standard and run. So those runs are selected based on randomization technique. You will have, depending on the number of factors under study, you will have minimum run resolution designs, like minimum run resolution 4, 5, 6. And you will have multi-level category factors. That will be one more design, multi-level category. Optimal, again these are customized factorial designs. Then there are miscellaneous like Karuchi and the optimal designs, etc. Now, morning what we saw the example was numeric factors what you enter as the design. Now, do you see something category? Now, what is this category mean? Numeric, as the name itself suggests, it is something you're going to add the numbers, like CCS level 5 to 10%, MCC 33 to 66%. So there are numbers, numericals involved. But now, if there is a situation where you have two different surfactants or two different disintegrants under study, like effect of cross-carbonyl sodium, effect of sodium starch glycolate, or magnesium stearate and sodium stearyl fumarate. Now, which lubricant or which disintegrant is better? Now, if you want to include these two types of material in the design, then you have to select category. That's the category you're selecting, rather than numeric. Understood where to use category?
Yes, sir.
And rest will be, you will have response surface, you will have all the CCDs, box bent and optimal, definitive screen designs. We will not go in detail for all those. Simplex lattice and screen designs. So now our aim is to do a factorial design. So do you see 2 to the power 3? First we have 3 factors which are to be varied at 2 levels. You click on that, and we also need to have 3 center points. Do you see center points per block? Did you notice here? Then click next. If you are not on the same page with me, let me know, I can wait for you. Okay, everybody on the same page? Now, this screen is showing you have selected 3 factors. Now you have to enter the name of those factors along with the units, and also low level and high level what you want to study. If you don't want to disclose your values, you can still keep it -1 +1 as default, or you can also change it to your actual values. Yeah. No, now we are supposed to enter factor A, B, C, their units and their levels, which are already present in the document provided to you. Can you start entering? Firstly, they gave particle size. The unit is microns. So is 10. Height is 30.
Unit micron.
No need to talk, I am only telling you.
Microns.
Right? So you have to just follow me.
Microns of
1 to 5%. 1 is low, high is 5, and finally
No talking, please.
ಲೋ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಕಣೋ ನನಗೆ ಲೋ
high level entered. You should say yes. I know they are proceeding next. I know some of you will be a little slow. Want me to wait?
Yes, sir.
So once you enter all these, you just need to say next.
MCC दाखला शीशा आले तंत्र MC स्टैंड अंतर शीशा पुढील एक
So what is this screen asking for? Responses. How many responses do you have?
4 sir.
You have 4 responses. So on the response, there is a up and down arrow. You need to increase the number of responses to 4. Okay? Start entering what is the response along with the unit. First is resolution and continuous.
लाइट ಎಲ್ಲ
Content information.
ಲೋಡಿಂಗ್ ಮೊಬೈಲ್ ನೋಡೋದು ಮೊದಲ शीशा ಹೇಳ್ತೀನಿ ಫಸ್ಟ್
ಲೋ ಇನ್ನೇನೋ ನೋಡ್ಲಿ
ಅದು ನೋಡ್ಕೊಂಡು ಮಾಡು ಬೋಲ್ಡ್
ಲೋ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ತಗೊಳ್ಳೋ
ಮಾಡು
ಮತ್ತೆ ನನಗೆ ಕಾಣಿಸ್ತಾ ಇರೋದಕ್ಕೆ ಮಾಡ್ತಾ ಇರೋದು
ಕಟ್ಟು
Flow function.
ಟಾರ್ಗೆಟ್
For flow function coefficient, you will not have the same line.
ಕಂಟೆಂಟ್ ಯೂನಿಫಾರ್ಮ್
It's actually not. Enter the responses and the units. That's it.
ಪರ್ಸೆಂಟೇಜ್ ಅಂತ ಲಾರೆಸ್ಟ್
ಲೋ ಆರ್ ಎಸ್ ಡಿನ ಹಾಕಿರೋದು
ಅಲ್ಲಿ 6% ಆಗ್ತದೆ
Any doubts? Somebody will deny.
ಇದು ಅಪ್ಡೇಟ್ ಚೆಕ್ ಮಾಡೋಣ ನೆಕ್ಸ್ಟ್
You will see this design forward. Usually, it is always recommended to be
Next.
more than 80% for each factor. But in this case, we have
ಏನು
60
ಕಾಣಿಸ್ತಾ ಇಲ್ಲ.
1. But still, you can further experimentation. You don't have to cancel or change the design. But I really recommend the design is assessing whether are these relation or these ranges are too wide. That's why it keeps on decreasing. So 80% is recommended. Even if it's 68 here, we can still go ahead. So you can ignore this thing and just move to finish. Click on finish.
ವಾ ಮುಂದೆ ಬಿಡ್ತೇನೋ
Who has got more than 11 experiments? Once you have these experimental runs, you just need to look for information on the left hand side. There is something called as notes. Now if you click this, you can enter the aim of the experiment, how these 11 runs down. If you want to capture observations or learning, you can record your own notes in this section. Then there is summary. Now summary will give you the details, how this design was created, which version of the software is used, how much time did the software take to build this design. You can see it's just 1 milliseconds to create this design. And it will also list the parameters of the variables along with units, lower values and higher values, standard deviation. So all this is a summary of the factors, whatever you have entered in the initial screen. Next is the graph columns. If you remember the 3D cube, here it's a 2D cube, you cannot see 3D. So it is showing at each edge of the cube you will have 2 experiments, 4 on top, 4 in bottom, 3 in center, that is the 3 central points. This is how the design is created. Evaluation will be part of the analysis, so we will not do it here. We'll go to design again. We'll go to the lab, conduct all these experiments. Once we manufacture, test for dissolution, hardness, flow function, and RSD. Already I have given the answers for you. Relevant to that particular design, like 2350.1, go to that answer, check carefully. Slight mistake, analysis will go wrong. Enter the values of the responses to the respective design only. So be careful. If everybody wants to do at a time, the best possible way is one person will tell 2350.1 and respective answers so that everybody can identify the design and enter the respective values. That will be much more convenient. Does anybody want to volunteer for this activity? Anybody from last balcony? Okay, I'm going to tell. I'm going to tell the responses. You are finding that respective design and entering the responses. The first is 3166.7. Everybody found that design? Resolution is 76.
35.
RSD is 3.8. FFC is 7.56. Hardness is 12.5.
3.8 ಮಾಡಲ 78.0
ನೆಕ್ಸ್ಟ್ ಏನು
3.8 ಪಕ್ಕ 7.56 ಅಲ್ಲೇ ರೈಟ್ ಆರು ಮಾಡು
66.7. 76.
ನಾನು ಆಗಲೇ ನೋಡ್ಬಿಟ್ಟೆ ಮಾಡಿದ್ದು
7.56. 12.5. Done?
ಬ್ರೋ
ಓ ಬರ್ತಾನಿಲ್ಲ
Next is 66.7. Resolution 84. 4.0 CU. 7.25 and 13.2.
23
35, 66.7, resolution 84, CU is 4, FFC 7.25, 13.2 hardness. Good. Next is 23 and 50. So this experiment you will see 3 times because it's a midpoint, a center point, which is replicated 3 times. Is it audible? So you have to be careful while entering these experimental responses. Let's start with first one. 23, 50, 91 resolution. 4.0.
1915 silence.
23
FFC is 6.62.
4
Hardness 10.6.
10.6
ನೀನು ಏನು ಹೇಳ್ತಾ ಇದೆಯಾ ಅದು ಮಾಡಿದ್ದೀನಿ ತಪ್ಪಾಗಿ ನೀನು
ಇವಾಗ ಸೇಮ್ ಆಯ್ತು
10/5
ಸೇಮ್
33
ಮಾಡಿದ್ದೆ ನೋಡಲ್ಲಿ
Anybody have a problem? Experiment number 4. That is again 23 and 50.
ಇದಾ
Resolution is 89.4.
ಇದು ಒಂದೇ ನಿಮಿಷ
RSD 3.9. Flow function 6.66.
ಅವಾಗ 10/5
FFC, sorry, hardness 10.9.
ಅದೇ ಹೇಳು 98.7 4.0
Next is experiment number 5.
09.
31, 33.3, 31, 33.5. Resolution is 77, 2.9 RST,
ನೀನು ಹೇಳು 31 ಯಾವ್ದೈತದೆ ಇದು ಹಾಂ
8.46 difficulty,
ಹಾಂ ಹಾಂ
hardness 8.3. Next is 10, 5, 66.7. Resolution is 99. 5.1 RST. 4.77 FST. And 12.9 RST. Next is 10, 1, 66.7. Resolution 99,
10 132
RST 5,
166
4.97
ಅಲ್ಲೇ ಹಾಗೆ ಕೂಡ
ಇಲ್ಲ ಇದು 99.7
ಲಾಸ್ಟ್ ಇನ್ ಥರ್ಡ್
and 13.5.
ಇಲ್ಲ ಕಣ
Next is another midpoint, that is 23 and 50.1.
23 50.1
Resolution is 92,
82
RST is 4.1,
23?
4.1
ಹಾಂ
23 50.1
ಹಾಂ ಹೇಳು
92
and hardness is 11.1.
4.1
6.46
6.46
7.3
Everybody completed up to 8 runs.
ಇವಾಗ ನಾನು 10 ಆಗೋಯ್ತು ಹೋಗೋ
Next is the 9, 35, 33.3,
ಅದೇ ಅವನು ಹೇಳ್ತಾನೆ
33.5.
ಇಲ್ಲ ಅದೇ ಹೇಳ್ತಾನೆ ಕೂಡ
86
Resolution is 86,
86
RST 3.2,
ಟೈಪ್ ಮೆಸೇಜ್ ಟೈಪ್ ಮಾಡ್ತಾನೆ 3.2
8.46
ನಿನ್ನ ಬಾಯಿಗೆ ತುರ್ಕೊಳ್ಳೋ ಏನಾಗ್ತದೆ
8.6 hardness.
ವರ್ಷದಿಂದ ನಡೆದಿನ ಕಡೆಗೆ 8.46 ಕಿವಿಗೂ ಸೇರಿಸ್ತಿರ್ಬೇಕಲ್ಲ ನೆಕ್ಸ್ಟ್ 8.6
Next is 10, 1, 33.5.
ಕಡ್ಡಿಲಿ ಲೋಯಿ ಎರಡು ಸ್ಥಾನೆಲ್ಲ ಕಟ್ಟು ಹೀಗೆ ಎರಡು ಸ್ಥಾನ
Resolution 99.5.
ಇವೆಲ್ಲ
ಇದೇನು ಮಾಡೋದೇ ಇಲ್ಲ
ಇದು ಸ್ವಲ್ಪ ಪೆಟ್ ಮಾಡೋ ಫೋನು
56.16,
ಕಟ್ಲಿ ತೋರಿಸಿ
ನೀನು ಮಾತಾಡ್ತಾ ಇರೋದೆಲ್ಲ ರೆಕಾರ್ಡ್ ಆಯ್ತೈತಿ
hardness 9.1.
ಬ್ಯಾಕ್ಗ್ರೌಂಡ್ ಮ್ಯೂಸಿಕ್ ಬೈ ಉಲ್ಲಾಸ್ ಕಾರ್ತಿಕ್
10, 5, 33.5.
ಕೋರಸ್ ಮಧುಸೂದನ್ ಏಳನೇ ಮನೆ
98.7 resolution.
ಬ್ಯಾಕ್ಗ್ರೌಂಡ್ ಸ್ಕೋರ್ ಅಂಜನ್
4.0 is the RST.
ವಿಡಿಯೋ ಕರ್ಟೇಸಿ ಅಬ್ದುಲ್ ನೈಮ್
6.09.
ಸಪೋರ್ಟಿಂಗ್ ಸ್ಟಾಫ್ ಸುಮನ್ ಶಾ
ಮಂಡೆಗಾದ್ರೂ ಈ ಕಡೆ ಇಲ್ಲ
ಗೊತ್ತಾಯ್ತು
Everybody has entered the values for all the 11 experiments.
ಗೊತ್ತಾಯ್ತಲ್ಲೋ
Who is no? Go back to software, feed in the responses, and then do the evaluation. Okay, are we good to start the evaluation? So we'll start the analysis. And we have to start with dissolution at 30 minutes. That is the first response we are going to evaluate. Version 13, we don't have any ratio of minimum to maximum. This is something new for me as well. So directly it shows no transformation. It's set to default. So no transformation required. we'll start the analysis.
Positive effect, negative
When
effect.
you see the half normal plot, did everybody get it? Now, if you remember the morning session,
Yes, sir.
anything which deviates the red line are considered to have a significant effect. Now, if you see in this plot, there are 3 points which are deviating from the red line. Now, if you want to see what are those factors, you just need to keep the cursor there. Once you see the plus sign, click on it. It will be showing that particle size, EPA particle size is having a significant effect. Now, what sort of effect? Positive or negative? You see on the left hand side, the color code. Blue color indicates negative. Next, AB, that is factor A and B. There is some interaction between the EPA particle size and the disintegrant level. Now let's look at the third factor, cross-carbonyl-sodium. These are the 2 factors and interaction which are deviating from the red line or standard line. So once they deviate the standard line, they are considered as significant. Based on the color, either it is positive or negative. So factor A is having a negative effect. Factor B has a positive effect. And an interaction also has a positive effect. Now, since you have already selected A, B, and C, by default, the next chart which shows the Pareto chart is already selected. If you don't want to see it in the half normal probability plot, just deselect it. Automatically, they will get unselected in Pareto as well. So instead of half normal, I will start with Pareto. Now, anything which crosses bond ferroni limit. Are you seeing the red line?
Yes, sir.
ಇದು
Single click on that particular block. That is the rank 1, which is allotted to that, because that factor has a significant impact on your dissolution. So it is crossing the bond ferroni limit. So EPA particle size has significant effect. Let us look which is the other factor which is having an impact. Slight impact, not significant here because it is below the red but above the value or the black line. Let's see what happens with clicking on B.
ನೋಡಿ ಸರಿ ಬಂತು.
Now the slight effect also exceeded the red line. So when there is an interaction of EP particle size with the cross carbonyl sodium, it will significantly impact the dissolution. That's why you will see even B exceeded the bond ferroni limit. What about rest of them? This is factor C, that is MCC, no effect. AC, no effect. ABC, no effect. You can ignore the rank 7. So we'll just focus on which are significant and we will not focus on which are not significant. So only highlight A, B, and clear till here?
Yes, sir.
I am going to do only dissolution. Next, this row will do for content uniformity. One from this row will do for FFC. One from this row for tabula. You don't have to come here and explain. Click on that numeric.
No.
You are on Pareto chart. The next step, Pareto is correct. So when I say factorial designs can be used for identifying the critical factors among a series of factors, how do we identify with the help of screening designs? It is the percentage contribution. You see this last column, percentage contribution from each factor to affect the response is considered to be significant. That is based on the contribution to that particular response, you will say which factor is critical and which is not. But there is no standard set, like if anything more than 10% contribution, then only significant. If anything more than 50%, then only significant. There is no set criteria or deadline. It depends on the number of factors you have and how much they are contributing to your response. Now in this case example, factor A, that is the API particle size, is contributing to slowing down the resolution almost 89%. So 89.296%, that's why it is significant. Whereas if you see MCC, it's 0.17, very negligible amount of contribution to the resolution. CCS 4.3, together A and B 5.2. Now when you are doing screening, it may not be mandatory that you have to study the interaction, you can just study the main effects. In this case it's only 3, so it's very simple. But when you are doing screening, you will have more than 15, 20, 25 factors. And in that, you need to, based on the percentage contribution by each factor, you can select which top 3 or top 4 can be optimized. So this is the answer for how to select critical factors from a series or list of factors when we are doing the screening. But here our aim is not to do screening, it is to optimize, but I just showed you where to find it. Identify which factor is critical and
ಝೂಮ್ ಮಾಡಿ ನೋಡೋಣ ಅದರಲ್ಲಿ ಕಾಣಿಸ್ತಿದೆ.
next, let us go to ANOVA. Analysis of variance. We will not focus on curvature, directly go to ANOVA.
ಯಪ್ಪ
If you remember, anything more than
ಕಾಣಿಸ್ತಾ ಇತ್ತು ಆದರೆ ಸ್ವಲ್ಪ ನೋಡಬೇಕು.
the model p value is less than 0.05 is significant. Now which factor is significant? Factor A, factor B, as well as interaction AB. All are significant. Now many times you don't have to review those numbers and get confused, because many times people get confused with 0.005 or 0.05 or 0005. So if you're not good at that, read the description in the blue box. You will clearly understand which factors are significant and which are not. Now in this case, A, B and AB. Any problem? Just for holding. Now once we look at ANOVA, the next thing is fixed statistics. Fixed statistics will show you the R square. Now you have to check out the difference between statistics and the related R square is less than 1. Please get your point. 0.975 is equal to 0.9. Still going with AB and AB. And also look at the adequate precision ratio. Signal to noise ratio, anything more than 4 is desirable. Your ratio is 33.43. Hence, it indicates an adequate signal. So this model is good and could be used to navigate the design space further. Artha
Yes, sir.
After R square fixed statistics, next thing to look is the regression coefficient or the coefficient estimates and write the coded equation. You will still remember y is equal to b plus b1a plus b2b plus b3c. Similarly, based on this coefficient estimates, you need to write the equation. The next coded equation you find a complete equation. What you need to do. This needs to be captured in the coded equation. Okay? For you, the software is made your life easy, then you get everything in the formula. So not always start with y. Y is equal to resolution at 30 minutes is equal to intercept minus 9.15. 89.90 minus 9.15. What relationship will
అదే 50% కాలేజీలో వస్తాయి, 50% నోటిఫై. చాలా
It is not going to diagnostics because this has different plots like box plot, and we have actual and predicted values which are not much important unless you are going for PhD or PhD. Now this will help you calculating the prediction errors. For them it will be important. For predicted versus actual. Based on the 11 experiments data, the system will try to predict what should have been the result. And that is the black line, slant line, whatever you are seeing, that is the system predicted result. But the points, the colored points, like on the lower side you are seeing the blue points. Now these blue points indicate your resolution was somewhere around 75-76%. And when you have this red points, it indicates higher resolution. So actually all these lines should fall on this straight line, but they have deviated slightly, not significantly. So the percentage prediction, actual versus predicted, is the difference is very narrow or very small. So that means you are still good to go ahead with your prediction or analysis. If they deviate too much, like let us say this point went on here or this point went on here, then there is some error which needs to be relooked. Like you may have to repeat some experiment, one or two experiment, just confirm that why only one experiment out of 11 deviated from the actual resolution. Otherwise, you don't have to worry. In this case, we are almost closer to the line and you don't have to consider it as a significant change. That's in the actual versus predicted. Next, let us go to model graphs. You see interaction here, or what is one thing is you can go here and change. Like I want to study one factor at a time.
ಇಲ್ಲಿಂದ ದಾಣ ಬಿಟ್ಟು ಅಲ್ಲಿ ಬಿಟ್ಟು ಅಲ್ಲಿಂದ ಎಳೆದು
ಪ್ರಬುದ್ಧರು only factor A versus resolution. Increase in particle size increases the resolution. Now this is factor A. Now if I want to see one section cross carbonyl sodium, what I will do? On the right hand side, you will see some flag. Right click on it and make as X1 axis. Now you will see CCS versus resolution. What is the effect? Increase in cross carbonyl sodium concentration is a slight increase.
ಅದೇ ತಪ್ಪು ಹೇಳ್ಬಿಟ್ಟು
And when you are doing this analysis, you should also try to correlate. You should, in your mind, in the back of your mind, Pareto chart, half-normal probability plot, the regression equation or the polynomial equation should be running in your mind. You saw that resolution was minus for factor A, right? With increase, there was a decrease. Whether the same thing is reflected in the figure. With CCS, there was a positive effect. There was a slight increase. So are you seeing any increase in resolution? Yes. So whenever there is one with MCC, no effect. So you should get a parallel line to x-axis. Let us see its indication. Okay. So no effect of MCC on resolution.
ಈ ಬೀಕಿಲ್ ಮುಂದೆ ಸಿಗೊಟ್ಟೋದ್ರ ಸರ್ ಬರ್ಬೇಕಿದ್ರಲ್ಲಿ ವೈದ್ಯಕರು
ಗೊತ್ತಿಲ್ಲ ಬಿಡು ನಿಮಗೆ.
Single screen. On the top, you can select all factors here. If you are not able to see, you can also do by dropping this graph. You can switch graph and you can select all factors. It's already selected here, so it's going down. So all factors. This picture you can see on your desktop and then copy into your notes. You want to show all together. If you go with one factor, what happens? The PC will increase from 200 to 400. Next is interaction. Now we saw there is an interaction between factor A and B. Together they have some interaction effect. So it's an increase in APA particle size. So when you see the interaction graph, there is a challenge here. You can see the scale of x-axis, but not y-axis. Sorry, the second factor on x-axis, cross-carbonyl sodium. If you don't know what is happening, in this case it will be reverse actually. You will start with low concentration here and goes to higher concentration. So increase in particle size, increase in the duration, increase in cross-carbonyl concentration, slightly increase in the duration, but the point at which both the lines collide and coincide, that is factor or the term called as interaction. They interact and the concentration at this interaction would be the ideally preferred for your final formulation. Something if you extrapolate this line here, 10 microns APA particle size, with around let us say 4% of cross-carbonyl sodium, because we have 1 to 5%, correct? So 1 is here, 5 is here. So something like 4 to 5 with 10 microns particle size will give you maximum resolution. That's why there is an interaction with a particular point where you will have the highest response. Next is, what plot is this? Contour plot, also called as 2D, also called as slicing. Slicing plot. You have to assume that the cake color of the cake, you have to slice, take this slice and do the elevation. So now we know that it's only factor A and factor B which are critical. So we have particle size, cross-carbonyl sodium, see the dissolution. Blue color is low dissolution and red color is higher dissolution, 99%. So I want red area. So the more the red, the better the dissolution. So with higher particle size, if I take this slice, if I have highest particle size, and if I study up to let us say 3% centigrade, I will have less than 80% of dissolution. If I reduce the particle size and further increase the centigrade, I will have up to 85%. Now, if I go with a minute particle, that is 10 micron, if I add 1% or 5%, I will still have dissolution more than 95%. If the particle size is the smallest will have more than 95% of the clear? Now the same conclusion we can also do in 3D surface. Now in this case, A and B, let us say you still want to see the effect of MCC. You just need to go to that ribbon or flag, right? Make it either x1 or x2. If you add x1, it will replace APA particle size, say x2, it replaces CC. We have one constraint.
ಸೊ ಸೆಲೆಕ್ಟ್ ಮಾಡುವುದು
CC does not have any effect. We have 33%. CC does not have any impact on the resolution.
ಈಗ ಹೋಗ್ತದೆ
Last 3 rows. If you want to gossip or murmur, you can walk out of the hall so that you are not disturbing rest of the other participants. If MCC had any effect, you will see contours. These lines are called as contours. You will see lines originating vertically as well, or it may go circular. But when you don't see anything originating from the x-axis and it's only y-axis, then only the parameter on y-axis will have an impact, whereas this x-axis will not have any impact on the resolution or the response. So the same thing you can see in 3D surface. Now we first see the effect of factor C, even though we know that it is not having any impact on resolution. You can rotate it as per your convenience, copy it and paste in your pieces of paper, such that you are able to give a clear visualization or clear explanation to your student. So turn it as you like. Just see here the effect of MCC. From 33 to 66.7. It's a straight or parallel line to the surface, correct? Are you able to see in your laptops? Yes. So that means it does not have any effect, which we already know. Let us see the effect of particle size. Increase in particle size from 10 micron to 30 microns. At 10 micron, you have a resolution somewhere around 98. And slowly, with increase in particle size, your resolution is dropping to 30 microns. So it's somewhere around 72 or 75. So increase in particle size decreases your resolution. So let's see what happens with increase in cross cannulus sodium. I'm going to replace MCC with cross cannulus sodium. Let's see cross cannulus sodium. 1%, 5%. Increase in concentration of cross cannulus. Slowly from 75. You just draw imaginary lines. Imaginary lines you have to draw here and understand this will be around 75. Slowly increasing. So from 1% to 5% you increase. There is a slight increase in resolution. Only up to 85. It's not very dominant. So in the range whatever you have studied, it can increase only up to 85%. There is an effect, but a slight increase. But if you want to increase to 100%, what you need to do? To go back to interaction graph, what we discussed there. If you have your API particle size 10 and you have some disintegrant between 4 to 5, you will see this area. This red zone are you seeing? That is where it is almost like 98 to 100%. That is, there are 10%, 10 microns API there, with 4 to 5% of disintegrant, you will get more than 95% of resolution. Clear? The content reform analysis. From this row, who is that wave for design space. Now with numerical optimization, you will get a n number of solutions. Now here you need to select your response. The response can be a single goal, like only I will focus on resolution. Content informative, select it from whatever it wants, I'm not worried, I want only resolution. Then only you will have a single goal. But if you want all your 4 responses to be within certain criteria, then you need to set a range that is seeking multiple goals. Now let's click on resolution. Goal is in range. Now if you go to hands up, in response to section number 4, After units, you have something target, right? Word document. Yeah. You want resolution more than or equal to 80%. So that means for me, minimum 80% resolution is required. Page number 1, serial number 4, in the tabular column, third column. Got it? So 80 is the minimum resolution I want. 80 and above is suitable for my formulation. Percentage RSD. Select goal as in range. Lowest can be 2.9, which is observed, or I can even put it as 0 because that would be the lowest. Highest I want not more than 5. So instead of 5.1, I will make 5.0. I don't want more than 5. FFC in range, I want more than 6. So my lower value becomes 6. Above 6, anything is acceptable. And finally, tablet hardness, I want more than 9. So I will change from 8.3, that is the minimum value of the 11 runs. I will change it to 9. So give me a design space or solution which will meet this criteria. Hardness. Once you set your goals, click on solutions.
20 ನಿಮಿಷ
Did everybody get this? Figures? Now these are graphical solutions. If you are not convenient with this, now in order to understand this, what you need to think is, if you see these red dots, those are the independent variables, blue ones are the dependent variables. So here, the red dot wherever it is placed, the API particle size is 16 micron, CCS is 4%, MCC is 53%. If you use this composition, you will get a resolution of 94%, RSD 4.3, FFC 6.1, and tablet hardness 11.3. And it is saying this is solution 1 out of 100. So for this particular study, you have got 100 solutions. So among 100, you can select any one. You can repeat that experiment in the laboratory and confirm the system predicted results for the actual result. If you want sheet, you directly click
solution. In solution, go in solution. Contour.
Yeah. ಏನೇನೋ
reports. In the reports, you will get 100 solutions. So all these 100 solutions will help you in achieving your targets for particles, for dissolution, FFC, hardness, and RSD. Clear on numerical? So out of this 100, you can so graphical, since you have already set your targets or goals for your numerical optimization, by default it will take the same values. So graphical already you can select 80, the minimum resolution. 5 is the maximum RSD. 6 is the FFC, 6 to anything more than 6, tablet hardness more than 9. And you just click on graphs.
Yes.
Everybody will get a design space. Now this color by default is yellow.
Graphic,
Whatever
graphic.
color you like. Now this yellow zone is the design space and the grey zone is
Again, I should do.
knowledge space. But if you want to meet your targets,
Go in tabular.
you have to do experiments within
Go in
that
graph.
yellow zone. If you do any experiment out of this zone, you will fail to meet your criteria. Let us say you did some experiment here.
And
Let us say
Correct, correct.
selected some point,
Correct.
and if you want to see what is that
Hey,
flag
correct,
you want to
Kanado.
see, you just right click and say add flag. So at that point, your resolution will be 96, CU will be 4.5, FFC will be 5.6, tablet hardness is 11. All are meeting your acceptance criteria except FFC. If want more than 6, right? So, but at this stage, we will have 6.
ಕರೆಕ್ಟ್ ಐತೆ ಇಲ್ಲಿ
6.12. What is page? Nothing is page.
ನಿಮ್ಗೆ ಗೊತ್ತಿಲ್ಲ ಅಷ್ಟೇ ಅಂತ
RSV for less than 5.
ಎಷ್ಟು ಬೇಕು ಹೇಳಿ
FFC,
ಮಾಡ್ಕೊಳ್ಳೋದು.
we wanted more than 6.
ಎಷ್ಟು ಬೇಕು ಹೇಳಿ ಮಾಡ್ತೀನಿ.
Tablet cardiac, we wanted more than 9. So it has not been considered because your API particle size, disintegrant concentration here is fixed at 12 and 3, whereas your MCC is standard 53.61. If you want to increase your design space, you can alter the MCC concentration. Now let us alter MCC. Let us say you have only 33.3% of MCC you can use. You cannot use more. What will happen if I have lowest amount of MCC in my concentration? No design space. So, yes. So you cannot proceed with 33.5. Let us say if you have 35.8% of MCC, you have much more area which will meet your target. Now, I am fixed with 50%. I don't want to have
ಏನೆಲ್ಲ ಸರಿಗೆ
more
ಸುಮ್ಮನೆ
or less. I want to stick to 50% MCC.
ಕರೆಕ್ಟ್ ಐತೆ ನೋಡು ಕಲರ್ ಆಮೇಲೆ ಪೇಂಟ್ ತುಂಬಿಸಿಲ್ಲ ಅವನು
If I have fixed my MCC to 50%, then still I can get some design space within which if you do any experiment, you will be able to
Printer link
stick
ಖಾಲಿ
with all
ಆಗೈತಾ?
the criteria. Let us say out of this,
Yellow color ಎಲ್ಲ ಖಾಲಿ.
I will say add flag. Now at this point,
Add
if I
flag.
conduct any experiment with 50% MCC, particle size of 22 micron and X2 that is CCS 3.1%, I will have 88% resolution, 3.8 CU, FFC 6.9 and RS 10.2.
ಅಯ್ಯೋ
So I can
ಹೊರಟೋಯ್ತು.
repeat this trial and collect the actual results. Then I can go to point prediction.
Where?
This is all after post analysis. I can go to point prediction. Now this is the system predicted values, predicted mean. Now whatever the values you got in your lab, you can enter here, the observed values, and the system will predict what is the standard deviation, that is the actual, and the predicted value, what is the difference, how much prediction error is
ಸಿಸಿ ಎಲ್ಲ ಹೊಂಟೋಯ್ತಲ್ಲ
made during the calculation. So that's how you will confirm. The lower the error or the lower the standard deviation, the better the formulation, the robust the formulation, because exactly it is predicting what the system is showing. So that's how you conclude your final formulation. What is the other aim of the experiment? So once you have a knowledge space. So based on the knowledge space, you can give the design space. Now how to give? Now design space, MCC, you are fixing one variable to be fixed at 50, and your design space will become, keep the cursor on the starting point of yellow zone. There the x1 is, can you see? And then at this point,
ಕೆ ಬಿ ಅಂತ ನೋಡ್ತವೆ ನಾನು
x1 that is API particle size is opening.
ಅಂತ 250
That is 1.01. And C is 50. So you can start from 14 microns, a particle size. This integrant can be 1.01. And you can have a design space up to.
ಇಂಡಿಯನ್ ಸೀರೀಸ್ ನೋಡ್ದ
So you cannot, you have to draw a straight line here, extrapolate this, and ignore the rest of the part, because down you have a gray area. So this will be your end point. So from 14 microns,
ಇಂಡಿಯನ್ ಸೀರೀಸ್
14 to 26 micron is the design space for API particle size. This integrant you have from 1.01, you can go up to this point.
ಕ್ಯಾಮ್ರಾದ ಬರೋಲ್ಲ
5%. 5%
ದೇಶಿ
at 50% of MCC. You are still, there is a possibility you can play with MCC also by varying the concentration. Let's say if you have 35, you are still able to meet. You can have like 35% to 50% of MCC suitable for your formulation. Understood?
Yes.
With that, I conclude the hands-on session. Now the session will be open for question and answers.